device name pipe called logger, and it's actually got the handle ID, which, you know, it's not quite as much information as you got with the GUI version, but it's good. So, what are these tools good for? Well, they're really great for getting started understanding the Windows IPC mechanisms. So if you are looking for communication across a privilege gradient, especially communication that's not trying to hide itself across a privilege gradient, this is a good place to start. They also get you thinking about what the ACL should be and let you kind of browse around and see what they're doing. You don't need any source code, so they're a real good way to get yourself kind of familiar with it. If you're going to do any programming with these types of things, you definitely want to play with these a little bit. It gives you a feel for what you're using. But they're not the right tool for short-lived objects. If I've got a named pipe that, you know, say I have a mail slot on my machine, and when someone connects up to it, I tell it, oh, here, connect up to this named pipe, and I give it a name, and I create that named pipe, and they connect, and we do a really quick couple of back and forths, and the whole transaction takes 10 milliseconds. I'm not going to be able to see that in Process Explorer. Even if it showed it on the screen, my eyes aren't that fast, and even if they were, my brain's not that fast. So totally the wrong tool for looking for that. But it's also not directly useful for fuzzing. It's good for identifying attack surface, and it's good for understanding the problem. So, more complicated, powerful tool. WinDebug, standard Windows debugger, totally multi-purpose, and you know, this is just one more thing it's good for. You can get it for free, which is nice. All these tools are available without charge. And it can intercept your kernel 32 calls that create all these IPC mechanisms, and that's really what we want. For name pipes, there's the create name pipe function. For shared sections, there's the create file mapping. And you know, I've got a little picture there of it seeing something. I'll show you a demo in a bit. I think it's probably the same image. Let's see, so what's good about WinDebug? Well, we're able to use this to actually alter program behavior. So instead of just seeing the IPC mechanisms, now we can actually set breakpoints on the creation of these IPC mechanisms and change the calls. If I want to change the parameters, I can just go right onto the stack and say, oh, you know, this pointer that you were pointing to this name, I'm going to point it to somewhere else. Or, oh, that memory that pointer pointed to, I can just change it in place. So they're useful for manipulating, very slowly, the creation of objects manually. So you can sit at your keyboard, and I guess if you're paid hourly, this might be a good way to go. It's certainly good to go a few times just to get the feel for what you're doing. Breakpoints, you know, we can extend the life of breakpoints. So if I've got that little problem I was talking about where when the client connects, the whole transaction only lasts 10 milliseconds, well, I can slow this down to an amount of time that I can actually read and you know, think about what's going on there. Also, one of the great things about WinDebug is that you can configure it as the post-mortem debugger. So whenever your fuzzer causes a crash in the application, poof, up this pops, and you've got the whole process memory, you've got the registers, you've got the stack, all there. You can save it to a file. You can hand it off to a developer. If you're going the I want to make a patch route, you can hand it off to them, and they can look at the stack and figure out what went wrong. If you're going the I want to write an exploit route, it's got all the offsets, and you're ready to go for writing your exploit code. What's not so great about it? Well, it's not really very graphical. I mean, it's maybe a little graphical, but it's not. It's kind of hard to start out with. And actually examining the contents of ACLs, you know, you've got this untyped information like, oh, here's what's on the stack. How many of these are actual parameters to this call? Why don't you look in MSDN? And then you can figure out what the calling convention is and, you know, figure out what all these parameters are and change them. So not exactly slick. And it's very difficult to use for direct fuzzing because of the manual nature. So, using WinDebug to intercept the creation of name pipes. So, we can do this for a couple of reasons. One is to discover IPC mechanism use, which is really still more of a feeling it out kind of thing. Or, you know, it can also be used for if you want to create a log of the SDDL. I don't know if you know about security descriptor definition language, but SDDL is a kind of semi-human readable way of describing the ACLs on a securable object. You can dump that, for example. And you can also use it to hook the IPC mechanisms for fuzzing. So I'm going to give a very brief demonstration of using it for discovery. So this is the very simple part. Fire up WinDebug, verify that my symbol path points to my symbols directory. The symbols that I have there are just the public symbols off of the MSDN or public symbol server. So nothing special here, nothing related to the code. Then I'm going to open the program I'm going to test. This program is called CallLogger, and it's included in the ISEC public IPC fuzzing tools that are on that little CD and available on our site. And I think BlackHat will make them available. And as soon as it starts up, what you see here, you see that? Good. Is we've got a little command shell going, and we've hit a breakpoint right off the bat. And this breakpoint just lets me do things like set other breakpoints before the actual application starts to run. So in here I'm going to say breakpoint kernel 32, bang, create named pipe W. I don't know if I mentioned before, but create named pipe, there's two versions of it, the W and the A. The A stands for multi-byte character set. Actually, it stood for ANSI, but remember, it's not ANSI, it's multi-byte character set. Those things can be international characters now. Didn't used to be. The W stands for WIDECAR, and those are Unicode characters. And all the A's functions do is convert the multi-byte character set to the WIDECARs and call the W's. So if you're hooking functions, stick with the W's and you're in better shape. Doesn't matter then what the program itself is doing. So okay, we've set a breakpoint. We take a look at the list. Sure enough, there's a breakpoint sitting there. So we're going to continue the program. And the first thing the program is going to do is listen on a named pipe by calling create named pipe. And sure enough, that causes our debugger to return without any output from the actual program itself. And we can take a look at what's on the stack. So it's a little command that shows what's on the stack. You can see here that the first couple of arguments are on the stack there. And the very first argument, if we looked in MSDN to create named pipe, is the name of the pipe to create. So I figure this must be a pointer to it. So I type in here du, which displays a Unicode string from a memory address. Type in the memory address, and poof, out pops the name whack whack dot whack pipe whack call logger, which is indeed the name of the pipe that I'm creating. So that's using WinDebug to see IPC mechanisms getting created. So that was possible, but not ideal. All we had to do was stick the breakpoint in, and up it pops. So the most interesting thing about doing this is that now that we understand it, we can build on it by automating it. So, middle person fuzzing. We might want to use a similar technique to actually fuzz this name pipe. So say we had an application, a server, that was going to create a name pipe named foo. And what we could do is we could use WinDebug or some other mechanism to intercept that call and change it to bar. Then we could launch our own name pipe named foo, and when clients wanted to connect to the server, they'd connect up to foo, and we'd forward the data to bar. So I'm going to illustrate that a lot more later, but we don't want to do it with WinDebug. We want to do it with something that's going to automate it so we can reuse our testing tools and we don't have to sit there and type all day. So we're going to use some code injection and hooking tools. And there's a bunch of them that are available. There's probably the first one. There's a good paper about it from Microsoft Research. It's called Detours. And it's a pretty powerful little system for doing this. There's, it's under a commercial license, however, and the commercial license is kind of pricey. So might not be good for trying out on the weekend. There's Matt Conover's BSD licensed x86 hook, which comes with a whole bunch of other utilities. It's not just a hooking system. It comes with things for regular expressions. It comes with things for services. It comes with a bunch of security code. It's really powerful. It can do disassembly. It can do all kinds of stuff. There's an URL for it. It's free, so that's what I've chosen to use for these demos. There's the API Hook SDK, which is a commercial product. That's available for a small charge. I haven't actually used it. And there's Mad Code Hook, which I think is kind of cute because it's written in Borland Delphi. And lets you hook stuff, and I programmed that in the 90s, so that was fun. Then there's the other option, and the other option is to do your own homegrown ghetto detours implementation. And some people like Scott Stender and Andreas Windstam from ISEC have done that. And if you're that kind of adventuresome person, go ahead. But my goal here is to do this quickly and not to necessarily explore the world of hooking. So I'm just going to use Matt's excellent code and leave those other ones be. But certainly different libraries might be appropriate for you. So, hooking injection. Hooking, it turns out, it's much more powerful than just for fuzzing IPC. You can use it for all kinds of things. You can use it for HIDs. You can use it for making your own ghetto version of strace that filters the parameters of system calls. You can do lots of cool stuff with it. Usually when you build a hook, one of the things that all those libraries do is they package it into a DLL. And DLLs are just the Windows shared library scheme. When you package your code into a DLL, it's easy to load in and it's easy to unload. It's easy to put initialization code in there. It's easy to get notified when threads attach or detach. So it's a really handy way to be able to do that. And my code, of course, is packaged into DLLs. As I mentioned before, the source is all available for all these demos. And they're all written in C. Can't really, I mean, you might be able to do something like this in Python, but C is the right language. So what we're going to do is we're going to use hooking to discover IPC mechanisms. We're going to do the exact same thing we did with WinDebug, only instead of setting a breakpoint, I'm just going to hook the API. So I'm going to use a program to inject my hook in. The hook's going to replace the start of create name pipe function with a little piece of code that says log out what pipe we're going to be writing to. So it's the equivalent of that DU statement and the looking up of the parameter on the stack. And then it's going to print that out. We'll see it, and we'll be all happy. One of the other things here is that we could have logged the ACL. We could take the ACL, convert it to SDDL, and log that. This is sort of a, that would be more for if you had a big set of tools that you wanted to go through and make sure, hey, every product that my company offers properly locks down the ACLs it exposes. And you might want to make something like that where it was more general than just for name pipes. And that's pretty easy to do, actually, because these hooks are really non-intrusive. But for that, probably have to talk to us or do it yourself. So I'm going to just do a little demo where I inject this hook into, I think, the same process. Maybe I'll use a slightly different program. Does the same thing, creates a name pipe, and I'll just log out the name so that we can see that we're doing it with code injection. And one of the things that you'll notice about this example is that it's going to be a lot easier to do. And so if you're actually doing this day to day, it's not going to be as boring, and it's going to be totally reusable, and the program is very short. So the first thing I'm going to do is, yeah, here we go.